All right, we are recording. So welcome everybody. My name is Heidi Baines. I'm a coordinator for EdTech at the Riverside County Office of Education. And this presentation today is on machine learning with Scratch 3. As we were waiting to start the session, we were talking a little bit about Scratch. I know there's some people that are brand new to Scratch and some people that are a little more experienced. So we'll talk a little bit today about what Scratch is. And then I want to talk about an additional tool you can add to Scratch that can mimic creating an AI machine like your Amazon Alexa or your Google Home. And when you think about how much artificial intelligence is part of our lives, and especially part of our students' lives today, it's a really neat way to introduce how that works to our students, because it's not just magic, right? There's programming and algorithms and a whole industry behind AI, and it's changing our worlds. And most of our students don't know a world without AI. I know my son, he's 13, and when he needs to know something, he asks Siri, right? That's just the go-to. And when he needs something from the Alexa, he talks to the Alexa. So all of these things that are such a big part of our world that have kind of crept into our world as adults, but are part of a world that the only world that our students have known. We're going to talk a little bit about how to get that knowledge, or at least that introductory knowledge, to your students in your classes. That's me. If you'd like to touch base with me, or if you have any questions after today, you can reach me at that email address. You can find me on Twitter at Baines Heidi, but please feel free to reach out if you have questions, if you'd like additional resources, or if you need anything else after today. There is my contact information. And again, you have access to these slides at bit.ly/StepCon20. That's pasted at the top of the chat. So you can open these slides through Google Drive, make a copy, and they are yours. Okay, so first, what is Scratch? And I was actually poking around in the Whova app this morning, and I saw some questions about this. So if you were one of the people that asked the questions, I went through and answered what was there. But Scratch is an introductory programming platform to help students learn the logic of programming and computational thinking skills. And it's done using blocks. It's a drag and drop program that allows students to drag the blocks in a certain order to make whatever they have on the screen do what they want it to do. So I'll show a short video for those of you that haven't seen Scratch before and don't know what it is. It's about a 3-minute video that'll just introduce you to the very basics of what Scratch is, and then we'll move forward from there. So let's see here. Here we go.
Scratch 3 is an interactive visual programming environment that works right in your web browser. It's ideal for kids. You can create interactive stories, games, and animations by simply dragging and dropping blocks. You can record your own sounds, draw your own characters, or even upload pictures of yourself. Here I'm going to do a quick demo. We will animate a Scratch cat and have them walk, talk, and make a sound. First, let's add a background. Next, let's add some blocks. Everything happens when you press the green Go button. So let's make a little event here. What we'll do is we'll start the cat on the left side. Then we'll make his legs move and make him say the word meow and also play the sound meow. So we go over here and we're going to repeat this. What we're going to do is we're going to move the cat 15 steps, and then what we're going to do is we're going to make his legs move. So what we're going to do is we're going to change him over here, and we're going to switch his costume to costume number 2. Then we will wait a little while, not too long, Then what we'll do is we'll go back here and we'll switch his costume back to his other costume of when he shuffles his feet. And we'll wait a little while. Next, we're going to have him talk. So we go over here and we say, we're going to have him say the word meow. Then what we're going to do is we're going to have him say the word meow. Now, let's make this a full screen and test it out. There it is. This is a really fun platform for kids to learn programming and problem solving with their parents. Visit nextlesson.com for free, easy-to-follow tutorials on programming in Scratch 3. Thank you.
All right. Thank you guys for letting me know about the echo. I appreciate that. I think was the rest of the sound okay? I think I got that figured out now. But for those of you that are new to Scratch, that's a really quick introduction to how Scratch works. Basically, students have what's called a sprite. And in this case, it's the cat on the screen. And you can choose multiple sprites and program multiple things. But the program takes place over here on the left that you can see still on the video screen. For example, that one says, when the green flag is clicked, do those things or repeat these things, right? So it's a way to logically lay blocks out to make the sprite or the cat do what you want it to do. If you're a math teacher or a science teacher and you're looking at those coordinates, great way to teach the coordinate plane. I know that's kind of an abstract idea for students. I know my son works with that 4-quadrant plane as well. And in Scratch, the way the sprites lay out is all on that coordinate plane. So if you're looking at ways to teach the positive and negative of placing something in those quadrants, this is a great way to do it and a really concrete way for students to see where they place that cat or where they place that sprite in relationship to the quadrants on the plane. We doing okay? Everyone out there? All right, thank you guys. So again, quick introduction to Scratch. And if you've never seen it before, if you go to scratch.mit.edu, or if you just Google Scratch, there are tons of resources about learning to use Scratch, and Scratch itself provides a whole bunch of projects that you can work with and that your students can work with to help you learn more about how to use Scratch. You can also set up an educator account so that you can monitor your students' progress and the projects they're working on in Scratch. This particular session isn't about those pieces, but those are things that you can do using Scratch if you're interested in kind of tiptoeing in and getting started with it. All right. In my slideshow, if you get my slideshow from the bit.ly, all of this is linked. So if you want access to these videos and these resources, everything is linked through my slideshow. So again, if you pull that bit.ly down and pull this up on your own screen today or later, anything I talk about, you can click and link to it. You don't have to go find it. As far as what the sprites can say, you know, that's a good question. I want to say that it filters out inappropriate language, but I think that might be a discussion to have with students before they create their projects. I think that's what you're asking, Harmony. I taught middle school, so I could see that being something they would have a lot of fun with, maybe not in the ways we want them to. Yeah, so that might be just a classroom management issue and talking to them about making sure it's school appropriate. Let me show you one more video. This is students talking about their experiences with Scratch, and it'll kind of give you a little better understanding of what they're doing with it and how it's used. So let me click over here.
3
nope,
is an interactive.
Not that one. Let's try that again. Here we go.
I was searching for interactive programming language on the internet, and I came across Scratch. As soon as I shared my first project, I got instant feedback, and I was like, okay, I want to continue with this.
I remember my first project was a super simple animation. I'm still actually really proud of my first project. It opened my eyes to the different possibilities that coding can present.
So I've been drawing basically since preschool when I learned how to hold a crayon. I think making art with Scratch is different because I can collaborate with other people and make something interactive that other people can use.
There was a song that said, "Happy, happy birthday." I put Scratch in there. It just became an instant hit on the site and inspired so many people to make their own songs and remixes.
Anyone can do anything with my project, and sometimes it's really funny how they change things at the end. It just goes to show like how much you can actually do with all the things you have in Scratch.
When you're looking at other people's projects, you're engaging on such a different level, which really encourages this kind of mindset of seeing yourself and each other as makers of things and not just consumers.
But I never thought that I could do like the coding part. Like I thought like I have to wait till I'm a grown up and like hire someone to code it for me. But then I was like, hey, I can actually do this myself.
It gets more complex, but once you know the basics, you can add on to your knowledge and move at your own pace.
If you like solving problems, if you like drawing, if you like making music, if you're into anything, Scratch is for you.
So that gives you another picture of what Scratch looks like, particularly for you guys that are new and haven't seen it before. The nice thing about it, even though we're talking specifically about machine learning and AI today, you can see all the different ways that students and teachers can use it to graphically represent things. You know, whether it's science, I think I saw a cell recreation there, or whether it's storytelling in social studies or language arts, or retelling a process or a scientific process or a math process. All of those things can happen in Scratch once you get to know the basics and practice with it a little bit. Yeah, extremely engaging. And, you know, and we talk about distance learning, engaging our students and maybe giving them different options to show what they know. This is one of those things that might engage students that might not otherwise be engaged in other methods of showing their learning. You know, and it's not that every kid is going to want to code and want to use Scratch, right? It's not going to appeal to every student, but it may appeal to those students that you're having trouble reaching in another way. I know I always use my son as an example, but he's a 13-year-old boy. He hates to write. I think that's pretty common with most 13-year-olds probably don't like to write too much, but he would be willing to do something in Scratch. So, you know, if there were some kind of balance between the way he could show his knowledge, I know Scratch would be one thing that he would be happy to choose to show what he knows, if that were an option sometimes instead of an essay, perhaps. All right. So a couple of things, especially for you guys that are new, or maybe you guys that are already experienced with Scratch. I'm a tremendous fan of the Raspberry Pi Foundation. They make a little computer that students can use at home, and it teaches you about the physical components of a computer. But they also create a ton of free educational resources. And so if you're new to Scratch and your students are new to Scratch and you just want to introduce them to the platform, this won't link here on my screen, but on my slides, this links to the Scratch tutorials that are created by the Raspberry Pi Foundation. And it walks you and or your students through step-by-step learning how to use Scratch through these different projects that they've created. And I only have 3 projects on the screen, but there are many projects on Scratch that you can get through the Raspberry Pi Foundation to help you or your students learn how to use it. So check out their resources, because there's a ton of them and they're free and they're fantastic and they're always adding to them. All right, so that takes us to today's specific topic, which is this thing we call an extension, which is made by a place called Machine Learning for Kids. I forgot the gentleman's name, but this is created in the UK. This is also free. It can also be used with classrooms. And a class account can be created. It's a little more complex than just a plain Scratch account. So there might be a few things you need to figure out to get this working widespread for a whole class. But the extension is called Machine Learning for Kids, And again, this is linked on my slides, and this is a live video on my slides. It's about 20 minutes long. So after today, if you want to learn more about this extension, you can watch this video, and this will also link to the Machine Learning for Kids website, so you can learn more about it. On the Raspberry Pi site, Redwood? Okay. Oh, just the tutorials in general. So my intention here is to go back and forth between live and slides. So I'm going to see how it works. If it becomes too cumbersome, I'll just stick to my slides. So let me know how you're feeling out there in the audience, and I can change it up for what works for you and what works for us in this session. But Machine Learning for Kids, let me flip over to my slide. I'm going to screen share here for a second. So Machine Learning for Kids, when you go to the website, it looks something like this. And again, this is this video that I've linked in my slides, but it tells you a little bit about what it is. It tells you a little bit more about what it's like to use this as a teacher account in your class. But then it also gives you the opportunity to create a project. So what I have here are some projects that I'm working on. These I create in Machine Learning for Kids, but then it will connect back to Scratch. So if you're interested in using this for AI, if you're interested in doing what we're doing today, it starts here with Machine Learning for Kids. And as we go through this process, it will connect back to Scratch 3. Let me go back to my screen. So does that make sense? So I'm gonna go back to my slides. So where we're starting today is if I were going to do this from scratch, or I was gonna do this with my kids, I would first go to machinelearningforkids.co.uk. And again, this is on my slides, and it's step-by-step on the slides as well. When I get there, so what you saw was me already logged in, but when you first get there, you'll have some different options. If you're following along with me today, or you just want to give it a try, or you want your students to try it, and you don't want them to have to make accounts or any of that, you can do this, try it now. And this will just give them the platform without collecting any student information and without having to go through that account creation. The next thing you'll see, and you didn't see this on my screen originally because I already have projects there, but I'll go back and show you. It'll ask you to add a new project. So to start a project and to start the project that we're looking at today, you would click Add a New Project. How are we doing out there? We're doing okay? Good, good. All right. Now, the cool thing about Machine Learning for Kids is it allows you to create a project that will either recognize the text you write in Scratch, it can use your camera to recognize images, it can recognize the input of certain numbers, or it can recognize sounds. So I'm going to work with text. And if I remember correctly, these free accounts and this Try It Now account will only look at text. But once you log in, you'll have some more options. So this project is going to read the text that we write on the screen and make something happen to the sprite. All right, I'm going to screen share again. We good? And when I screen shared last time, you guys could see that and hear it, right? There were no issues. I didn't see any things. Okay, so I'm going to screen share again. All right, so here I am live on my screen again, and you'll see that option to add a new project. So if I was going to start from scratch, and if you're following along with me now, you would click Add a New Project. And when I click add a new project, it asks me to name it. And you could see mine was named Light It Up. So I named mine Light It Up. And then I opened it. And now here's what I have. So I'm going to train the computer to recognize certain words. The computer is going to run its own test and learn those words that I input. And then I'm going to make something with it in Scratch 3. So that's the process. You train it, it tests it, and then you use what the computer has learned to create a program in Scratch to do something. So on my slides, when I click train, you'll see this step by step on the slides. I've already created it here in the interest of time, and it's done something strange. So I'm going to take all these things out that say text. But these little buckets are the places where students would input information that it wants the computer to learn. So in other words, when the program sees these certain words, it's going to have different reactions. So in this case, when I write something in my Scratch program that says turn the light on, a light is going to turn on in Scratch. I'm going to show it to you in just a second. Same thing, when I write the word light off or make it darker, the computer's going to recognize that, and that's going to mimic a light turning off in Scratch. And you can see how this would connect to the real world with students and the smart home and the smart devices that we have nowadays. This we're going to mimic through a sprite in Scratch. So it's not going to turn off the real fan in my room, but it will turn off a fan sprite that's been created in Scratch. All right. So I fixed those. So let's go back. How are we doing? Let me check in. Doing all right? Yeah, Sonal has a UK bias. And to be fair, I learned about this in the UK, so it was really exciting to learn about this from the guy that created it. I wish I had the depth of knowledge that he does, the creator. He was able to answer every question about it, which I'm not quite that deep in my knowledge, but it's super cool. All right, so you can see this is on the screen. I created the project. I named it Light It Up. I opened it up. And again, these are my slides. You have a copy of them if you wish, and everything is laid out step by step if you want to do this. So you train, you add a new label, which you saw on my screen. I created those buckets. So each of those are labels. And when I click that, I named it. And when I share my screen, you'll see them again. But one was light on, one was light off, one was fan on, and one was fan off. So I named each of those buckets according to what actions I wanted to happen according to the words that I input. All right, so here's what it looks like before it's filled in. So you saw mine all filled in, but you open up this bucket and you have light on. And at the bottom, it wants you to add an example. So when I click add an example, that's where I type in what I want the computer to recognize. To run this program, you have to have a minimum of 6 examples. Excuse me. So each bucket, each label needs 6 examples of what you want the computer to recognize. Okay? We doing okay? So far, so good? Is anybody following along with me? We all just listening, which is totally fine. If anyone is following along and you want to give feedback as you go, please, please feel free, okay? All right, so you can see on my screen adding an example. So you click add an example, and then it starts to look like this, like you saw mine on the live screen. So now it tells me that there's 6 here. And if you don't put 6 in, it will tell you. And you can do more than 6 as well, but 6 is the minimum. And I circled this over here because I know that I've had this page open before, and I've said, well, gosh, how do I get back to the other screen? And I just couldn't see where it said back to project. So once you do this part, to go back to that screen where you can train and test, you need to click back to project. So I'm going to do that live. I'm going to flip back over to my live screen and show you that next piece. So here I am. I've created these labels. I've put in my examples, and I'm ready to move on to the next step in my project. So I'm going to go back to project, and now I'm back to this original screen. I've already collected examples of what I want the computer to recognize. And so now I'm going to learn and test. Now, for the sake of this presentation, I already did the learn and test portion. But when I click that, you'll see that it'll take me to this page, and it reviews what I've done. It says I've collected 6 examples for each of those labels, and then explains what's next. So it says, try testing the machine learning model below, enter an example of the text, and see if it works. So this is kind of the fun part, because I've put certain phrases in each of the labels that I want to work. And now I can test them here before I get heavy into programming in Scratch. I can test them out here. So I can say, turn on the light and test. And it recognizes that as being part of the light on label with 90% confidence. So the computer is 90% sure that when I type turn on the light, it wants the light to turn on. And that's pretty good. One of the other labels was light off. You can go down a rabbit hole with this. You can test them all. You can type in all kinds of weird stuff, and it'll show you the testing level and the confidence percentage. So light off, it recognizes with 100% confidence. So it knows when I write light off that I want that light to turn off. So here we go. Let's say, make me a sandwich. So it recognizes sort of something there, but it's not confident and understands what you want it to do. And something with that low a confidence level, something's gone awry, right? It's not functioning correctly, and it shouldn't, because it shouldn't recognize make me a sandwich, because that wasn't one of our labels. All right, so once you've tested it and once you've put in a few of those phrases and you're certain that it's working correctly, you go back to that, back to project. So let me stop sharing and check in with you all. See how we're doing. Yeah, can it make coffee? Right? Good. And you know, if I were doing this with a class, I would probably generate some ideas first. Maybe they put them on Post-its, or if you're virtual, maybe you're doing a Google Jamboard, and have them put up phrases that might be useful for what they want to control. So this is something that you could kind of crowdsource with your kids before they sit and look at a blank screen, because looking at a blank screen is really hard. All right. Jolene, I don't know the word limit on what it will recognize. That would be something fun to test out. But in regular Scratch, you could have a sprite reading a passage. So you wouldn't need necessarily this AI piece, but in Scratch itself, you could have a sprite reading or speaking a passage of something that you wanted to deliver. So far, so good. All right, and I know it's a lot of information, especially if you're new to Scratch, but we're going to flip over to Scratch here in just a second. So you've set all this up, you've learned, you've tested, right? You're pretty confident it's working. Now we've gone back to this screen, and we're going to click Make. And when you click Make, you get some options here. So if you happen to be a computer science teacher, or if you're heavily into program and you wanted them to do this with Python programming language, you could even use Python with this. I haven't done this with Python. I've only done this with Scratch 3, but that is an option if you are teaching something even more advanced and you wanted to integrate this with Python. Yeah, so this is the fun part. So now I'm saying, okay, I've trained my machine model and I'm going to now code it in Scratch 3. So I would click Scratch 3 and you'll get this screen, and it gives you some tutorials on what it's going to look like when you open Scratch 3. When I go live in a second back to Scratch 3, I'll show you those live. But you'll go here, you open Scratch 3, and now you have your Scratch 3 platform. But the great part is this is a completely blank platform, right? And for myself and for students, it's kind of hard to get started with a blank screen. So machine learning for kids, when integrated with Scratch, I don't know if you can see this on my screen, but there's a big red circle at the top and it says Project Templates. When you open that, it'll open a whole series of templates that you can use that will get you started with the code. And then you can change it for what you want it to do. So you won't have to have a completely black screen or blank screen. It will give you at least the blocks to get started. And if you look here again at my screen, you'll see the project templates up at the top. And then there's another red circle. It's really teeny tiny, but it says light it up. And what that is in addition to the traditional Scratch blocks, now there's an extension that's been added called Light It Up, which I created, right? But I created through Machine Learning for Kids. You'll create your own and name it what you want. But you can see that extension has been added to Scratch, which gives you a series of new blocks that you can use for your AI machine when you're working in Scratch. So here's the templates I was talking about. So and I'm gonna do this live for you in just a second as well, but when you get into Scratch, that circle up there that said Project Templates, again, you click on that, and there's all of these projects that you can do where the skeleton code has been created for you, and that will automatically populate your workspace in Scratch. And there's cool stuff in here, integrating with Twitter. There's, the visual recognition. Here's a sorting game. There's all kinds of things that you can do that they've already provided templates for. So when you open the template, this is the one we're looking at. So your template will look like this. And you can see the template has already created for you the fan and the light. So this project is going to focus on the programming only and not the process of creating these different sprites, which is another process that you'd have to go through if you started this completely from scratch. So using the template, you've got your sprites that you're working with. So you can see why I chose fan and light, because the template provides those for me. I don't have to create those sprites on my own. So I have my fan and my light and this skeleton code that I'm going to customize so that it does what I want it to do. But again, this was all part of a template. I didn't have to do any of this from scratch. I just said templates, it chose the one I wanted, and this loads on the screen. And again, I'm going to go back to my live page in just a second, but you can see here, this next slide, I added a few blocks. And I know it's tiny. It's tiny for me. I'm sure it's tiny for you, but you can see that I added in recognize text for fan on and recognize text for fan off. So these are the commands that I need to add in so that when I'm typing these words into the screen, the fan and the light will respond. So let me go back. So this is the template. And you can see the next slide is the first bit that I added. And again, this is all on my slides. You have access to all of it. And I've done it step by step on the slides. So when you want to go back later and do this, hopefully it's broken down enough that you can follow it step by step and will be successful. So here's a close-up of what it looks like. So I'll talk about this block in a second, but I've added recognize the text and the answer for those labels. Remember those buckets were called labels. and turn the fan on. Recognize the text for the label fan off, right? Recognize the text, turn the light on, recognize the text, turn the light off. These additional blocks that I added that say add training data, that makes it possible for me to go back to that machine learning for kids page and add in new things that I want the computer to recognize. And this will go out and get those things and add them to the bucket of, apologize, my gardener's walking by and my dog is barking. But adding the training data will make Scratch and machine learning talk to each other in those buckets. So if I have those 6 original light on commands and I add 6 more, this additional block will continue to grab those and recognize those. So that's add training data. That means add any data that I add in those buckets and recognize that as well. All right, so let's go back. How are we doing? I'll screen share and show more of this right now. Okay. How are we on time? I haven't even looked. All right, we're doing all right. So I'm going to screen share again. And here we are. So again, this is my project completed. And I showed you on the slides how it started with that template and then different things that I've added here. But if you can see my screen a little better than when it was on the slides, here's the templates. And there's just tons of them that you can use. Zombie escape, recognizing different fruits. So there's all kinds of things that you can use here. If you want to filter it by just projects that recognize text, they're here. Projects that recognize images. So a lot that you can use with the templates. This one that I'm showing you right now is Smart Classroom. And it's this one that's called Smart Classroom Easy. And I see that it's appearing several times. I'm not sure why there's repeats in here. But this particular one that you're seeing today is called Smart Classroom Easy. And so here I am. I'm going to go back. And you can see the code here. It started with that template. I added in, recognize the light on. And then I added an extra piece, and this isn't necessary, but I added this piece in that says recognize text for confidence level. So if I write something in that it doesn't understand, if it is less than 50% confident in what I've written in, it will return the message, I'm sorry, I don't understand. So this isn't a necessary piece, but it's just an additional piece so that if you write something that it doesn't understand, it'll give you feedback. Otherwise, if I don't have this in here and I write something it doesn't understand, it just won't respond. So you really don't need this piece, but if you'd like to go further or you have those students that want to go further, this is a nice, if this happens, do this, else do all these other things. So I'm going to run it. So to run something in Scratch, whether it's this program or whether you're just making your cat walk, I click this green flag, and now it says enter your command. And you see in the code, when clicked, ask, enter your command. So that's what it's doing. And I say fan on. And I hit return. Oops, it didn't go. Let's say light on. There we go. So light on, and my light turns on. And then I say light off, and my light goes off. Let's do the make me a sandwich again. If I say make me a sandwich, I spelled it wrong. You'll notice that it says, I'm sorry, I don't understand, because it's not recognizing that. Remember, that was that 33% recognition factor. So because that was such a low recognition, it gives me that I don't understand message. What happened with my fan? Let's see. Something has gone strange with my fan. Where are you, fan? Oh, something got moved around when I was messing with this. All right, so I have to fix my fan on thing, and I won't make you watch me troubleshoot this, but it's right in here somewhere. It's gone funky. Let's try that again. Oh, okay. I'll come back to that and take a look. If you see it in my code where I've got something running funny, we'll come back. Something I clicked on did something weird. That's okay. So I'll go back and troubleshoot that in the process of getting ready. I was clicking on a bunch of things, but you could see like when I typed in turn the light on, the light comes on. Turn the light off, the light goes off. Ideally, when I say turn the fan on, the fan will spin, and I'll show you the video of it, and then turn off and the fan stops. And so, you know, you could have, you could go deeper with that and giving it more commands and more things for it to recognize. You could add additional sprites, but in just getting started with it, the basics there of downloading that template and then working through the process of connecting the labels to what it's recognizing is a really good exercise in just learning to use the tool. So here is, oh, I didn't load this video. Let me grab this video and load it in the system. So here it is working correctly. Let me go back here. Forgive me. It's going to be tiny, but you'll see the fan come on and off. So I've typed here, this was a different program that I did, but you see the fan come on, and then the fan will turn off. And then the light comes on, light comes off. And again, you have a link to this too if you want to see it working, or if you want to show your students an example of it working. This is in my slideshow as well. All right, how is everybody doing? And I know it's a ton of information. If you're brand new to Scratch, go, start with that cat. I wouldn't start here with the machine learning piece. Start with that cat. Get to know, how to make the cat move on the screen. Start with the tutorials that are available. Scratch has tutorials built into it that you can work through as well. But as you get more comfortable with Scratch, and if you want to, kind of tiptoe into this machine learning and this AI, machine learning for kids will be that bridge that can get you there. So here's the code, and now I'm going to have to change this picture out because I can see where this code got messed up when I took a picture. So I'll change this picture out so that it's right. So if you're using it for reference, it will work in your Scratch. This is another Raspberry Pi resource. Throughout the pandemic, they have been creating a digital making at home series where they have videos every week of them creating different projects. And they're like 30 to 40 minutes long, but they are coding step by step with several different levels. So they have like a beginner's project and an intermediate project and an advanced project. So if you're looking for something to give your students that might be a choice or, an extra piece of engagement that you want them, to have fun with at home, this has been a great series that's leveled for your students' different learning styles or whatever they want to do in Scratch. So if you have some kids that are brand new beginners, they can do the beginner one. if you have a kid that's a little more advanced, they can choose that. But like this one was all about making games. So one was an archery game, one was a game about cats, but it was all the same theme of making a game, just different levels of programming knowledge to do it. And they walk you through step by step by step. They're really, really well done. Oops, before I go into this, any questions? How are we on time? 11:45. All right. Doing all right? Yes, Mary Elizabeth, perfect. I agree. So, and that's part of what I'm going to say next in my slides is, you know, when we all went home, my favorite thing is the hands-on learning projects and the engineering and the coding and, you know, making things light and making motors go. And when everyone went home, a lot of that was lost. And so since we've been home, I've been trying to think of ways or introduce ways that we can kind of mimic that and bring that back to our kids, whether it's at home or whether it's in some kind of some combination when they get back to class, whether it's hybrid or a blended learning environment, ways to keep them engaged in that computational thinking and that engineering without necessarily having those physical pieces in front of them. So I know we have educators from all over here. We have a couple of things coming up in our county. If you happen to be a computer science teacher or you know somebody who is, this is for secondary, but we have a Riverside County programming competition, and it's for students that it's a competition. It's competitive, but it's students programming. They get several different programming problems that they have to solve. And they are kind of racing to get it right and by time. And then we have winners according to how well they did in the competition. But if you're in Riverside County, generally this is for grades 6 through 12. It's students, for the most part, that are in computer science courses. It doesn't have to be. You could have some programmers out there that aren't in computer science classes. But if you know someone that teaches computer science or have a student that is interested and does some programming, we'd love to have them sign up for the programming competition that's in April, and that will be virtual. And again, that's for Riverside County students only for this one. But another event we have coming up in May is the Computer Science Showcase. So if you have students creating something in Scratch or creating AI machines with machine learning for kids, or you have kids working with Lego projects or any of those things, maybe they're doing something with code.org, anything that you might be doing that is computer science based, or if you know someone, and this is for all kids everywhere, any place, any county, all ages. So no matter where you're from, if you're here and you're a teacher and you have students that you're working with, we'd love to have them be part of our Computer Science Showcase. It's going to be mainly asynchronous, meaning students will submit links to their projects and we'll be showcasing those through a showcasing platform that we don't have set up yet, but on the web, you'll be able to go and see the project that student created. Again, anyone, anywhere, K-12 students. We did this a couple years ago in person and it was a tremendous amount of fun. There's a few of you here that were here or were there. Last year we had to cancel because of the pandemic, so we're back this year with it and excited to host it virtually. Sonal Patel from San Bernardino County Superintendent of Schools is here as well, and we're partnering on this event. But again, open to any county, so Riverside, San Bernardino, anyone around here, all of California, if you got friends across the country, their students are welcome to submit a link and showcase their work at our Computer Science Showcase. Sonal, do you want to add to that? I know you're here somewhere. I don't think you can access a mic though. But if you want to add, please add to that in the chat. And Marcia was there a couple years ago with Lego. It was a very popular room with all the Lego stuff that people could try out and play with. Yes. Another opportunity, if you're interested in learning more about coding, or if you want to learn more about Python, I talked briefly about it when we were looking at it in the resources. We're hosting a Python workshop. It's free for teachers, and it's on October 14th from 3:30 to 5. Excuse me. It's in partnership with a vendor called Skillstruck that creates computer science pathways for districts, but you don't have to be part of Skillstruck or, be using Skillstruck to then come to the Python workshop. So if you're interested in learning a little more about Python and being introduced to the Python programming language, October 14th at 3:30, doing that. And this is a group I run. Again, this is for any county. So Riverside, San Bernardino, or if you're from another county, you're welcome to join us. We have a group called the IA Makers, and it originated out of a bunch of maker spaces that are in our schools out here in the Inland Empire. These used to be in person, and we would do hands-on making activities. They'll be virtual this year, but we'll be focusing on things that you can do virtually to keep up the engineering and kind of bridge that gap between what you might be doing hands-on in school and what the kids can do while they're at home. So if you're interested in joining and being part of that group, you don't have to come to all the meetings, but here's the meetings and registration links here. And again, you're welcome to join us, and we'll be doing some of what I did today and introducing things that you can do from a distance. Thank you, Laurel. It was so fun last year, I know. The hands-on stuff and the in-person stuff, we've had a blast in that meeting. I have a website. It has some of my presentations on it. It's not a fabulous website. It's not fancy, but if you're looking for this presentation or other slideshows that I might have created that you could use with your students, you're welcome to anything that I've created and anything that's on there. So that's my website. Again, it's not anything fancy. It's really just a big bunch of slideshows that I've created, and I'll put this one there as well. So if you don't have the bit.ly, you can have this, and anything else that I have on my website is yours. But other than that, I think I made it through everything just in time. And again, I know that's a ton of information in a little bit amount of time, but can I answer any questions for the good of the group? And if not, I think we'll stop the recording here in a second, if I can find where to do that. Or we might not stop the recording. Yeah, we're going to keep the recording rolling. Then we'll close it up, and then I'll stop it. So I see a hand up. Sylvia. Oh, I see some Q&A. Oh, here we go. So Jolene asked a question a little while ago. Is there curriculum that students can learn the basics? In Scratch, there are tutorials that are built in. I think, Redwood, that might have been what you were referencing, now that I come full circle with that. There are actual tutorials built into Scratch that will walk them through how to get started in Scratch while Scratch is on the screen. And Jenny, great question. Do teachers need to be an expert at these programs? Nope, not at all. Using the tutorials and learning a few of the basics, your students can get started, and chances are they'll probably start to teach you a few things. I know when we worked with students in my previous district, students were always teaching us. So, you kind of give them the basics, and then they'll take off with it. And if there are questions, or if your students get stuck, it's that opportunity to kind of just learn along with them. There was always well, I don't know the answer to that, so let's see if we can figure it out together. And I know when we were working with coding and students, there was a lot of that, because I'm not a programming expert. I'm a social studies teacher. And so all of these things have come by either learning on my own or learning with students and making a whole lot of mistakes and just kind of powering through them. Oh, hello, Miss Leonard. Thank you. Sylvia, I see a hand, but I don't see a question. I'm happy to answer it. Otherwise, thank you guys so much for being here. I appreciate you coming out, and have a wonderful time at StepCon. Enjoy the other presentations. And I think most of your students will be coming tomorrow, right? I hope they have a wonderful day. And again, thanks so much. Feel free to reach out if you have any questions, or you want to work through something, or you want me to test something. I'm happy to do it. So, grab my email and send me a message, and I'm happy to help you. Thank you, guys. Thank you, Mary Elizabeth. Thank you. Thank you. Thank you, guys. Thank you, Crystal. Thank you, Chantel. Thank you, Rosa. Thank you, Juana. Thank you, Jane. Thank you, everybody. If there are no questions, I'll probably close up the room. Thank you, Phil. I didn't see you there. Good to see you. All right. Thanks again, everybody. I'm going to close up this room and have a wonderful time at StepCon. Bye, all. You know, so you'll have the whole production.
So what we hope to be doing, like 3 seconds before, we're not
No.
we're going to be doing something, and if you say 3, 2, 1 now, and we look up and go, hey, welcome back, or welcome to the magnet.
Exactly.
Because we're already doing something.
Exactly.
And someone just came in.
We're going to run it like you professional forever. We're do this right now. We're going to make you guys like Hollywood stars.
Hollywood. Ooh. Okay, good. So
What are those?
One of the galaxy, another one for the future right there.
Oh boy.
There's 3 of them. We can give away to the teachers.
It's true.
So for the classroom, oh my gosh, this is amazing. Do you want to talk to Kim about that? There's 3 of them. One is about the universe and the other one is 2 of the future.
I appreciate it. Thank you.
Wow.
Yeah, and they're huge. These are not standard poster size. So this would be
It's really nice.
so
No, but I saw
one
on Instagram or something. I got some,
I have the walkie, so if you need me, I'm already on.
Okay. As long as at 2:30 we're gonna, I'm gonna have to get on. That's the only thing.
Where are they going?
I know, huh? Okay, so this done.
all right, this is good.
I love the way you thought about this being able to move those very easily.
Okay.
The only reason I was thinking of the monitor on that corner is just because you can see from here.
No, you can't. I